Dear students, welcome to today's class. Today I am going to explain 5 problems basically from algebra. Okay now, so all these problems are very important for your next JEE Mains examination. Okay, so the first problem is, if alpha and beta be the roots of the equation x square minus 6x minus 2 is equal to 0, if an is equal to alpha power n minus beta power n for n greater than or equal to 1, then the value of a10 minus 2 times a8 by 2 times a9 is. So a10 means what? Alpha power 10 minus beta power 10. So a8 means alpha power 8 minus beta power 8. So those values you have to find. So this was problem given in 2015 mains examination. So options are also readily available. So let us see the problem solution. So here it is given that alpha and beta are the roots of this equation. Therefore we have alpha square minus 6 alpha minus 2 is equal to 0. So from this alpha square is equal to 6 alpha plus 2. Similarly, beta is also a root of this equation, that is equal to beta square minus 6 beta minus 2 is equal to 0. Therefore, beta square is equal to 6 beta plus 10. Okay now, so next we will take this, we want first alpha power 10. So to get a10 we get, a10 means what? Alpha power 10. So alpha power 10 how we will get? If you multiply with alpha power 8, you will get, first I want to find out this a10 value. Okay now, so this is equal to alpha power 10 is equal to 6 into alpha power 9 plus 2 into alpha power 8. For this also you multiply with the beta power 8. So that is equal to beta power 10 is equal to 6 into beta power 9 plus 2 into beta power 8. Okay. So we want alpha, first you subtract from alpha power 10 minus beta power 10. Why? A10 means what? Alpha power 10 minus beta power 10. So therefore this is alpha power 10 minus beta power 10 is equal to 6 times alpha power 9, 6 times beta power 9. So 6 times alpha power 9 minus beta power 9 plus 2 times alpha power 8 minus 2 times alpha power 8. So 2 times alpha power 8 minus beta power 8. Okay now. So alpha power 10 minus beta power 10 means what? A10. This is A10. 6 times A9 plus 2 times A8. Okay now. Now coming to your problem. A10 minus 2 times A8. So take this problem to this side. So this is equal to A10 minus 2 times A8 is equal to 6 times A9. Okay, we want 2 times A9. Okay now, so take this 2 times A9 this side, A10 minus 2 times A10 by. So this is a 2 times A9. Here it will come 3. 2 3s are 6. 6 times A9. So your answer is option 3 is the right answer. Okay now, such a very easy problem. So don't, general students what they will do? No, they will start substituting here. So this is alpha power 10 minus beta power 10 minus 2 times alpha power 8 minus beta power 8 divided by 2 times alpha power 9 minus beta power 9. They start doing this. So if you start doing, you can get the answer, but it takes a long time. Okay now, so if you calculate this way, this is a very short trick method. So I hope that you understand this solution. Let us go for next problem. Dear students, welcome to second problem. So for any three positive real numbers A, B and C, if one equation is given 9 times 25a square plus b square plus 25 times c square minus 3ac is equal to 15b times 3a plus c, then what are they? Whether B, C and A are in GPA, B, C and A are in APA, A, B, C are in APA, A, B and C are in GPA. Okay. So this is a very easy problem. So try to find out A value, B value, C value separately from this given equation. Okay. So multiply, first of all you multiply with 925, sir. So you take a total total terms to one side. So this is 925 are 225a square plus 9b square plus 25c square minus 75 AC. Take that side. So 45 AB minus 15 BC is equal to 0. Okay. So try to, can I write down it as a perfect square? This can be written as a 15a whole square. This is a 3b square. This is a 5c square minus 75 AC. 75 AC means, so this can be written as A and C. So that is a 15A into 5C. 15 5s are 75 AC minus 45 AB. 15A into 3B. So 15A into 3B minus 15 BC. That means 3B into 5C is equal to 0. So if you observe, this is of the form, this is of the, just like algebraic identity. We have an algebraic identity, that is a square plus b square plus c square minus ab minus bc minus ca. So a square plus b square plus c square minus ab minus bc minus ca. This is nothing but 1 by 2 of a minus b whole square plus b minus c whole square plus c minus a whole square. We have one algebraic identity. Okay now. So what is that? A minus b whole square, a square. Here one a square will come, a square plus a square, 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. All 2 will come outside and cancel. Ultimately you will get this answer. So that means a square plus b square plus c square minus ab minus bc minus ca is equal to how much? 1 by 2 of a minus b. Here a means 15a minus 3b whole square plus b minus c. That means 3b minus 5c whole square plus c minus a. C minus a means 15a minus c whole square is equal to 0. Okay now. So 15a minus 3b, 3b minus 5c, and again 15a minus 5c. 15a minus 5c whole square is equal to 0. Okay now. So if you observe, so 2 will also go to right side and becomes 0. So this is a square plus b square plus c square. That means if it is wherever x square plus y square plus z square is equal to 0. Here x, y, z are positive real numbers he is saying. Therefore we have x is equal to y is equal to z is equal to 0. Compulsory. Should be. That means 15a minus 3b should be equal to 0. 3b minus 5c should be equal to 0. 15a minus 5c should be equal to 0. Okay. So 15a minus 3b means 5a minus b is equal to 0. So this is 3b is equal to 5c. So this is a 3a minus c is equal to 3 5s are 15. So 3 5s are 15. So from this we can say that we can equate this. So see here 15a, otherwise you can write down as a 15a is equal to 3b. 15a is equal to 0. Therefore 15a is equal to 3b. 3b is equal to 5c. You here 15a minus 5c is equal to 0. Therefore 15a is equal to 5c. So from all these things you can equate 15a is equal to 3b, 3b is equal to 15c, 5c is equal to 5c, 5c is equal to 15. These three quantities you can equate to one another. Okay. So let us continue our problem. So dear students, welcome to the remaining solution. So here 15, 3, 5 are there. So these we can divide with 15. So you divide with 15. So this is a is equal to, so this is a by 1 is equal to b by 5 is equal to c by 3. Okay na? So let us call it as a some lambda. Let us call it as a lambda. So a is equal to lambda, b is equal to 5 lambda, c is equal to 3 lambda. So if you observe a, c, b, a, c, b, otherwise or b, c, a, that means lambda, 3 lambda, 5 lambda, they are in AP, they are in AP. Otherwise b, c, a, that means what? b, c, 5 lambda, 3 lambda, lambda are also in AP. So if you observe the answer BCA, so this is a BCA. BCA are in AP is the correct answer. Okay. So very easy problem. So if you know the identity, the solution is very easy. Okay. So let us go for next problem. So dear students, welcome to third problem. The value of 21C1 minus 10C1 plus 21C2 minus 10C2 plus 21C3 minus 10C3 so on 21C10 minus 10C2 is what? So if you want to find out the value of this problem, this expression, so this is a binomial theorem. This is from binomial theorem. So you should know one very important result. So that is this NC0 plus NC1 plus NC2 plus so on NCn is equal to 2 power n. This is the formula. Sum of the binomial coefficients. Sum of the binomial coefficients is 2 power n. That means from starting from NC0, NC1, NC2 up to ending NCn. Okay now. So given problem is 20C1 minus 10C1. Observe here 20C1, 21C0 is not there. 21C0 is not there. Okay. So I will do one thing. All 21 terms I will write in a one bracket. All 10C1, 10C2, 10C3, these terms I will write down in another bracket. Just generally everybody will do like that only. So this is equal to 21C1 plus 21C2 plus 21C3 plus so on. Observe here 21C10 minus. So this is a 10C1 plus 10C2 plus so on 10C10. Okay now, right. Now it is very clear what are the first step I did is all 21, those I have put in one bracket, all 10s, 10C1, 10C2, 10C3, 10C10 up to 10C10 I put in a bracket. So if you observe up to here the solution is very clear. Up to here if you observe NC0 value is 1. From this it is started NC1, NC2 so on NCn. That means 10C1, 10C2 so on. That means NC0 is not there. That means 10C0 is not there. So 10C0 value is equal to how much? 1. Take to that side. So this is becomes 2 power 10 minus 1. Okay, very clear. 2 power 10 minus 1. Okay, clear. But what about this? What about this? 1, 2, 3 up to 10 only. So what about the remaining terms? So that means some more terms will be there. 21C11, 21C12 up to you should have 21C21. Up to 21C21 you should have. So if you observe sum of the binomial coefficients, for example, if you are x plus y whole cube is there, x plus y whole cube. So how many terms will be there? 4 terms will be there. So what are the binomial coefficients you see here? 1, 3, 3, 1. So these are the binomial coefficients you will have. Observe sum of the first 2 binomial coefficients is equal to sum of the next 2 binomial coefficients. That is 1 plus 3, 4, 3 plus 1, 4. Like that x plus y whole power 5 also, x plus y whole power 5. What are the binomial coefficients? 1, 5, 10, 10, 5, 1. So these are the binomial coefficients 1, 5, 10. Observe the sum of the first 3 binomial coefficients is 16. Next sum of the next 3 binomial coefficients is also 16. So from this what you say, whatever may be the sum, 21C10, from that 21C11 to again 21C21, the sum will be half. So this is the, that means this is half of the 21C1 plus 21C2 plus so on 21C21 minus this is 2 power 10 minus 1. So this is equal to 1 by 2. So this is also 21C0 is not there. That's why this is equal to 2 to the power of 21 minus 2 power 10 minus 1. Okay now. So from this you multiply with 1 by 2 inside. So you will get this is 2 power 20 minus 1 minus 2 power 10 minus 1. Open the bracket. So 2 power 20 minus 1 minus 2 power 10 plus 1. Minus 1 plus 1 cancel. 2 power 20 minus 2 power 10. So 2 power 20 minus 2 power 10 is the correct answer. The only thing here you have to remember that half of the 1 to 2. Here sum of the first two binomial coefficients is equal to the sum of the remaining binomial coefficients. Half exactly divides the half. Okay na? So I hope that you understand this solution. So let us go for next problem. Dear students, welcome to fourth problem. Let f be a real valued function defined on the interval minus 1 to open, minus 1 to 1 such that e power minus x times f of x is equal to 2 plus integral 0 to x under square root of t power 4 plus 1 dx for all x belongs to minus 1 to 1. And let f inverse be the inverse function of f. F inverse be the inverse function of f. Then f inverse of 2 whole dash, that means first derivative of f inverse of 2 is equal to. Right. So this is a problem of both functions and integration, both algebra and calculus. Okay. So let us solve this problem. So first we will find out f dash of x. F dash of x we will find out. So from this we cannot get f of x. So first to find out f dash of x. To find out the f dash of x, so differentiate this function. Differentiating with respect to x on both sides. So this is a function is e power minus x f dash of x plus f of x into, that means u into v by parts formula, e power minus x as it is, f of x derivative is f dash of x plus f of x into e power minus x derivative is e power minus x, again minus x derivative is minus 1. So I can keep minus 1 here, minus here. So this is equal to 2 derivative is 0 plus here differentiation of integral means we have to apply the Leibniz formula. Leibniz formula. How to apply Leibniz formula? First you put upper limit x in this integrand, that is equal to root of x power 4 plus 1 into what is the derivative of x? 1 minus substitute 0 here, 0 plus 4 plus 1, 0. Again derivative of 0 is 0 only. So that means the second part will become completely 0. Right. So if you observe here, so you can take e power minus x common outside. So this is f dash of x minus f of x is equal to under square root of x power 4 plus 1. Okay now. So this implies f dash of x minus f of x is equal to e power x times root of x power 4 plus 1. Okay now, that means I have taken e power a minus x to right hand side. So from this f dash of x is equal to f of x plus e power x times root of x power 4 plus 1. Right. We got one function f dash of x, one function we got here. Clear. Now coming to the second data. What is the second data? F inverse be the inverse of the function f. F inverse be the inverse of the function f. That means f is an identity function. From this we can say that, so this in notation I can write it as f inverse of f of x is equal to how much? X. F inverse of f of x is equal to how much? X we can write it. Okay now. Now what I am going to do is, see here what we want, f inverse of t whole dash means first derivative you want. First derivative, if you find out f inverse of x whole dash, in place of x we will substitute 2. Okay. For this what you will do? Differentiating with respect to x on both sides. So this is equal to f inverse of f of x whole dash, that is the first derivative. Again f of x derivative is f dash of x, that is equal to 1. Yx derivative is 1. Okay now. Now from this, coming to the given problem, let us see what happens. Let us see what happens. We want f inverse of 2. When x is equal to 0, what happens? What is the f of x value? Okay. So up to here, put one thing. Now coming to when x is equal to 0, let us see what happens. When x is equal to 0, what is f of x value? So e power 0. f of 0 is equal to 2 plus 0 to 0. That means this whole becomes 0. Okay. So, when x is equal to 0, your f of x value is 2. Your f of x value is 2. See here, e power 0. So, e power 0 is 1. So, this also will become 0. So, where f of x value is 2. Okay, now. So, if you up to that, next we will substitute wherever f of 2. F of 2. So, f of x value is equal to how much? 2. We will substitute here 2 and we will get the conclusion. So, let us continue the solution. So, dear students, welcome to the remaining solution. So, this is equal to f inverse of f of x whole dash is equal to 1 by f dash of x. So, this is implies f inverse of f of x whole dash is equal to 1 by f dash of x value already we got. So, f dash of x value we got, that is equal to f of x plus e power x into under square root of x power 4 plus 1. This is the value we got, f dash of x. Just to you go through. So, when x is equal to 0, f of x value is equal to how much? 2. So, wherever f of x is there, substitute 2. So, this is equal to f inverse of 2 whole dash is equal to 1 by 2 plus e power 0 into root of 0 power 4 plus 1. So, this is equal to f inverse of 2 whole dash is equal to 1 by, so e power 0 is 1. So, 0 plus 1 is also 1, 1 into 1, 1, 2 plus 1, 3. So, this is 1 by 3. So, 1 by 3 is your right answer. So, just a very logical problem. This is it. It contains both algebra and calculus part, both. So, understand. So, I hope that you understand this solution. So, let us go for next problem. Dear students, welcome to fifth problem. Let omega be a complex cube root of unity with omega not equal to 0. A fair die is thrown 3 times, right? If R1, R2, R3 are the numbers obtained on the die, then the probability that omega power R1 plus omega power R2 plus omega power R3 is equal to 0 is. So, try to understand the problem. So, this is both complex numbers and probability, a mixed problem. So, first one, omega is a complex cube root of unity. So, whenever he is saying that omega is a complex cube root of unity, so immediately we know one result, 1 plus omega square is equal to 0, omega cube is equal to 1. So, that is the first result immediately we have to get. So, here what he is saying, R1, R2, R3 are the numbers obtained on the die. One die is thrown 3 times. One die is drawn 3 times. That means this R1, R2, R3 belongs to the set of numbers 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 such that omega power R1 plus omega power R2 plus omega power R3 is equal to 0, should be is equal to 0. What numbers we have to take from 1, 2, 3, 4, 5, 6 such that if you substitute here R1, R2, R3 that should be equal to 0. This is asking to probability. So, first sample space, how many points will be there in the sample space? That is equal to n of s. N of s, the one die is thrown how many times? 6 times. For one time the number of points in the sample space is 6. For 6 times means 6 into 6 into 6, that is equal to 6 cube. Okay na? So, those many number of points will be there in the sample space. Now, coming to what are the numbers you have to select from R1 from the sets 1, 2, 3, 4, 5, 6 such that if you substitute here R1, R2, R3 you should get 0. So, we have the result 1 plus omega square is equal to 0, omega cube is equal to 1. So, I will take after sample space. So, favorable events I will take. So, favorable events. What are the favorable events? You see, observe here. First, I will take 1, 2, 3. I will take 1, 2, 3. Is it one favorable event? Why? Because y power 1 plus y square next to y cube. Is it not equal to 0? Yes, it is one favorable event. Next one is 1, 2, 3. Next one 1, 2, 6. 1, 2, 6 is also one favorable here. Why? Because omega power 1 omega square, here omega cube and omega power 6, that is also omega power 6 means how much? Omega power 6 means omega cube whole square, that is also 1. That means omega plus omega square plus omega power 6, that is also one favorable cases. 1, 2, 3, 1, 2, 6. Again you will have 1, 5, 3. So here omega square will know, if you multiply with omega cube, nothing will wrong. Again omega cube value here. So 2 plus 3, 5, 1, 5, 3. Again you will have 1, 5, 6. This is also one favorable cases. After here omega power 1 into omega power 5. Omega power 5 means omega square into omega cube. Again omega square you will get. Omega power 6 means omega cube whole square. Again you will get omega cube. Omega square you will get. Again you will get 0. Okay now. So another favorable cases is this is a omega, no? Omega. So you multiply with omega cube. Nothing wrong. Why? Because omega into omega cube. Omega cube is 1. So therefore, again you will get here sample space 4, 2, 3, 4, 2, 6, again 4, 5, 3, again you will get 4, 5, 6. All these numbers are favorable cases. You substitute here R1 value, R2 value, R3 value, you will get 0. How many times you are get? 1, 2, 3, 4, 5, 6, 7, 8. So this is equal to 8. If you observe 1, 2, 3, 1, 2, 3. If you put here 1, 2, 3, 3, 2, 1, 1, 2, 3 like this, again this can be done in how many ways? All these numbers can be done in how many ways? 3 factorial ways. 3 factorial. That means what? 1, 2, 3 is one option. 2, 3, 1 is option. That means 3 2s are 3 factorial means what? 6 events will come. That means omega. For example, omega power 1, omega square, omega 1 plus omega square, see here 1 plus omega square plus omega square, you will get 0. So if you observe that, all will get, you will get the answer. Okay now? So right, so 3 factorial. So total probability is equal to how much? Total probability is equal to number of favorable cases. That means 8 into, and each this ordered triplet can be arranged in 3 factorial ways. That is equal to 3 factorial by 6 into 6 into 6. That is equal to 6 into 6 into 6. 3 factorial means 6. That means 2 4s are, 2 3s are, 2 2s are, 2 3s are. So this is equal to 2 by 9. 2 by 9 is your correct answer. Okay na? So very logical problem. This is very nice problem. Okay, so I hope that you understand this solution. Dear students, I hope that you understand today's all problems. Okay, in the tomorrow's class with some more problems, I will come before you. Okay, so until then, goodbye.